This video goes with Kuta handout number 13, which deals with the exponent rules. So we're actually looking at the handout itself, but before we get to the handout, I think I want to go back and maybe just write down the rules so that the students kind of have like a cheat sheet to look at. So I'm over here and I just have a blank piece of paper and I want to write down the rules pertaining to exponents. And before we do that, we probably should talk about just what an exponent does to a math problem or to a number. So the first thing I want to do is just write down just an example of what we're talking about here. I'm just going to pick a number right here. I'm going to say 6 to the third power, or 6 cubed. And when I look at this right here, you know, the big number on the bottom is called the base. And of course this number up here, this little number at the top, this is our exponent. Or sometimes we refer to it as our power. So exponent and or power. And we actually have two exponents or two powers that kind of have nicknames. So I want to talk about those real quick too, just in case students see them. So the two exponents that have nicknames would be if we take something to the second power, like 3 to the second power, that has a nickname where we can say it could be 3 squared. So if the students hear me referring to something squared, it just means to the second power. And of course the other nickname that we need to talk about would be if we had 3 and we raised it to the third power, we can also say that that could be 3 cubed. So those are our two nicknames. Okay, and then, well, what type of an effect does an exponent have on a number? Well, let's just take 6 to the third power and see what it really looks like. This is the effect it has. 6 to the third power, or 6 cubed, really equals an expanded form. It means this. It means 6 times 6 times 6. Okay? So we're actually, the exponent tells us how many times to multiply the base. And in this case, we would be doing it 3 times. So we have expanded form. And then, of course, we have exponential form. And we're going to be working with just trying to put things in both of those forms today, really not getting an answer yet. So we don't need to multiply 6 times 6 to get 36, and then 36 times 6 to get 216. We don't need that yet. Okay? We're just going to be working with that. Just these forms, and then, of course, the rules. So I'm going to extend my page right here. We're going to start about the first rule. And the first rule deals with multiplication. And if you're multiplying exponents, the rule is this: if the base is the same, we're going to keep the base. So keep the base, and we're going to add the exponents. So we will add exponents. And we'll give an example of that. Just spell that correctly. Okay, so we'll give an example of that. Let's just say we have this. Let's say we have 4 to the second power times 4 to the third power. In expanded form, that would really be 4 times 4. That would be the 4 squared, times, and then 4 cubed would be 4 times 4 times 4. And if we wanted to simplify that, we would say, well, how many 4s do we have now? Well, that would be 4 to the 5th power. So we can apply the rule without writing out an expanded form to find our answer. We can just say, okay, let's just keep the base. The base is 4. And what are we going to do with the exponents? We're going to add them. So that would be 2 plus 3. This is going to equal 4 to the 5th power. So that's what I would like to see the student work on their paper, is basically this. Show me this right here so that I understand that they're actually applying the rule correctly. The next rule that we have deals with division. So if we're dividing, now the division rules just say this. keep the base. And remember, the bases have to be the same, so keep the base. And then we're going to subtract the exponents. And let's give an example of that. So let's just say that we have 3 to the 4th power, and we're dividing that by 3 squared. If I wrote this in expanded form, it would be on the top in the numerator 3 times 3 times 3 times 3. In the denominator, it would be 3 times 3 for 3 squared. Students should know that if they have numbers both in the numerator and denominator, they can cancel them. So 3 goes into 3 once, 3 goes into 3 once, 3 goes into 3 once, 3 goes into 3 once. And so what do I have at the top? Well, I have 3 squared, because I got 2 of them left, over 1, and anything over 1 is just the numerator, so 3 squared over 1 just becomes 3 squared. Well, if we apply the rule would be, well, why don't we just do this? Why don't we keep the base 3, and let's subtract the exponents. And remember, it's got to be the numerator, subtract the denominator. So what is 3 to the 4 minus 2 power? It would be 3 to the 2nd power, or 3 squared. So I want the students to use that rule, okay? But then there's also an extension of this rule, because sometimes we get negative exponents. So let's give an example of this where we might get a negative exponent. Let's take 2 squared divided by 2 to the 3rd power. I'm going to change that. Let's do 2 to the 5th power. So we have 2 squared divided by 2 to the 5th power. If I use my rules, it's going to be keep the base. Let's subtract, but we're going to do the numerator minus the denominator exponent. So this is going to become 2 to the negative 3 power. And anytime we have negative exponents, we need to change them, or we don't need to, but in this case, on the handout, we need to change them to a positive exponent. And how do we do that? We just remove this, or move this down to the denominator of the ratio, so it's going to be 1 over 2 to the 3rd power. We would leave it like that. So if you have a negative exponent, you just have to bring it downstairs to the denominator of a fraction, and it changes it to positive. So be looking for that on some of the problems on the handout. And then, of course, our last rule, that deals with the power of a power rule. And basically, the power of a power rule states this, that you're going to multiply the exponents. So you will be multiplying the exponents. And let's give an example of that in a second. So here would be a good example of a power of a power. In parentheses, I have 2 to the 3rd power, or 2 cubed. All of that raised to the 2nd power. And if I was to write this in expanded form, it would really mean this. 2 to the 3rd power times 2 to the 3rd power. Because remember, this exponent applies to everything inside the parentheses, so we're actually multiplying that by itself 2 times. Well, if I wanted to simplify this a little bit more, 2 to the 3rd power means 2 times 2 times 2 times 2 to the 3rd power means 2 times 2 times 2. So what does this really equal? Well, now I have 2 to the 6th power. Well, we can kind of simplify this and say, wait a minute, why don't I just do this? Keep the base 2, and let's multiply the exponents. What is the 3 times 2 power? Well, this equals 2 to the 6th power. So that's your rules for the power of a power. Let's do a couple examples on the handout, and remember you have this to refer to. My first set of 20 problems just basically applies the rule of when the base is the same and you're multiplying exponents, keep the base and add the exponents. So for problem number 1, I'm going to keep the base 7, and I need to add 3 plus 4 plus 2. This is going to equal 7 to the 9th power. I'm going to do problem number 2. I'm going to keep the base 3. I'm going to add the exponents 2 plus 2. This is going to now be 3 to the 4th power. Problem number 4, I can't simplify this. The bases are different, 64 and 8, different bases. I guess I could take the square root of 64 if I wanted to. I'd be curious to see what's on the handout, but right now I can't simplify it unless I did the square root of 64 times 8 to the third power. This then would become 8, because the square root of 64 is 8, times 8 to the third power. Now I'm thinking, wait a minute, 8 to the first power times 8 to the third power is going to be 8 to the 1 plus 3 power. This is going to equal 8 to the fourth power. Let's see, let's do problem number 5. This is going to be keep the base, 4, and then remember there's an exponent 1 here, so it's going to be 1 plus 2 plus 4. This equals 4 to the 7th power. So students can apply that first rule, keep the base, add the exponents when they're multiplying exponents that have a common or the same base. My next group of problems deals with division. Remember, we're going to keep the base, and we're going to subtract the exponents. Remember, numerator minus the denominator. So this becomes 2 to the 2nd power. Right here, I have keep the base, so it's going to equal 4 to the 2 minus 1 power. That's going to be 4 to the first power, or just 4. Anything to the first power is the number itself. 25 is a good example. Here I have 7, that's my common base, to the 3 minus 3 power, which equals 7 to the 0 power. But anything to the 0 power equals 1. And by the way, that should make sense because any number over itself in mathematics is 1. So 7 cubed divided by 7 cubed does equal 1. So apply that rule for this group of problems. And then my next group of problems deals with the power of the power rule. And here I would just like to sit there and remember multiply my exponents. So keep the base 5. And what am I going to do with the exponents? Multiply them. So I have 2 times 2. This equals 5 to the 4th power. A good example here, 2 to the 2nd power raised to the 2nd power. Keep the base 2. Multiply the exponents. 2 times 2 equals now 2 to the 4th power. If I do number 42, keep the base 5. Multiply the exponents. 2 times 4. This equals now 5 to the 8th power. Let's see, 44, keep the base 5, multiply the exponents, 4 times 3. This is going to equal 5 to the 12th power. This is the work that I would like to see on the handouts.